Hi, everyone. In this video, I will be demonstrating mediation analysis using process model number 4 in SPSS. And I'm going to start out with a little bit of a background on mediation analysis, and then we'll proceed to the demonstrations. The first example will entail a simple mediation model. The second example is going to build on that simple mediation model by adding in covariates. And then the third demonstration is going to entail a parallel mediation model that's being tested. So before I get started, I do want to mention that underneath the video description, you'll find a link to the SPSS data file that I'm working from, so you can download a copy of the data to follow along. I've also created a PowerPoint, a supplemental PowerPoint that's going to provide a lot of details, perhaps some conceptual clarifications that maybe I'm not able to get to in this video. And so I encourage you to download a copy of that to follow along. And just so you know, the data that we're going to be working from is actually based on an article that was published in PLOS ONE by these authors right here. And the article is Prediction of Intention to Continue Sport in Athlete Students, a Self-Determination Theory approach. So we were able to obtain a copy of the data under the supporting information, and so that's how we're going to proceed. Just so you know, though, the models that we're going to be running are not going to be exactly the same. We're not going to be replicating what the authors did. We're just kind of using their data in order to carry out the demonstrations. So I'll also include a link to this article underneath the video description if you would like to read more. So briefly, what is mediation analysis? Well, basically, if we kind of citing Hayes right here, we can say that mediation analysis is a statistical method that's used to evaluate evidence from studies that are designed to test hypotheses about how some causal antecedent variable X transmits its effect on a consequent variable Y. So the basic idea with these types of models is that we're assuming that X and Y are related to each other causally, where X would be a cause of Y. However, the influence of X on Y, perhaps maybe it is transmitted through intervening variables. And those intervening variables are called mediators. So as you're looking at the two figures on the screen right here, you'll see we've got two different models. The first one is a simple mediation model, where we have X predicting Y with a single proposed mediator, and that's the M that we have right here. So the mediator is sort of the proposed process or mechanism that helps to relate X to Y. In the model on the right, there are actually two proposed mediators. We have mediator 1 and mediator 2, so that the effects of X on Y are proposed to be transmitted through two mediators. And certainly we can generalize this out to multiple mediators. We don't just have to stick with just two of them. So let's go ahead and start just by talking a little bit about the simple mediation model. And I've already kind of highlighted, the characteristic of it, or the main characteristic, which is that there is a single mediator. So we have essentially right here, we have an X antecedent variable, we have our Y consequent variable, and then we have M, which is again is our mediator. You'll notice that we have single-headed arrows pointing from X to M, then from M to Y, and then also X to Y. And we have paths that are labeled A, B, and C prime. Okay, so basically each of those single-headed arrows represents a proposed causal association between the variable that's kind of at the head and the variable at the end of each of those arrows. So basically each of those are referred to as direct effects within our model. So A reflects the direct effect of X on M, B reflects the direct effect of M on Y, and then C prime represents a direct effect of X on Y. And if that C prime is actually significant, that would kind of assume that the effect of X on Y may not fully be transmitted through M, but also maybe there's some residual effect that is direct, or at least maybe there's some unmodeled mediators that could be considered in the future. So this is our conceptual model of a simple mediation model. And like I said, we've just kind of specified the direct effects. And one of the things that we end up doing when we're testing our simple mediation model is we want to test the indirect effect of X on Y. So we want to test whether there's evidence that's consistent with the idea of mediation, or with the proposition of mediation. So if I assume that the effect of X on Y is mediated, then we want to quantify that effect. And we can do that by taking the product of paths A and B. So in a nutshell, you'll see down here in our little PowerPoint slide, I just kind of mentioned that the quantification of the indirect effect of X on Y is A times B, or path A coefficient times path B coefficient. And we can test this out to determine if it's statistically significant. When we use the process macro, we're actually using nonparametric bootstrapping in order to generate a confidence interval, and then we can carry out our hypothesis test of the indirect effect using that confidence interval. One last thing that I'll mention before we kind of move on is that if we take the direct effect as given by the path C prime right here and add it to the indirect effect, which is the product of paths A and B, then that actually is equal to what's called the total effect of X on Y. So to estimate our paths in our model, with A and B actually going into the computation of the indirect effect, we're essentially using least squares regression, at least within the context of the process macro. If you were using something like a structural equation modeling program, then the estimation approach most likely is going to be maximum likelihood. But with the process macro, it relies on least squares regression. So path A is basically, in this particular model, is going to be estimated using a simple linear regression where the mediator, or the proposed mediator, is regressed onto the antecedent variable X, and then paths B and C are estimated through a multiple regression where the consequent is regressed onto variables X and M. So here's our parallel mediation model. And just kind of giving you an idea about what it would look like. Again, this just has two mediators, but theoretically we could incorporate any number of possible mediators of the effect of X on Y. But in this particular model right here, we have X, we have M1, M2, and Y. And as we're looking at it, you can see that we've got path coefficient right here, A1, which reflects the direct effect of X on M1, and A2, which is reflecting the direct effect of X on M2. Then you can see that we've got B1 right here and B2 right here, reflecting the direct effects of M1 and M2 on Y respectively. Then finally, we have path C prime right here, which might reflect any residual effect of X on Y that's gone unspecified, perhaps through other possible mediators that just were not included in the model. So that's basically our direct effect. That's essentially a direct effect there. So all of our path coefficients in this model, you can see, are direct effects of one variable on another. Now, when we talk about the indirect effect of X on Y, it actually flows through two routes. So we could trace from X to M1 right here, X to M1, and then M1 to Y right here. Okay, so if I take the product of paths A1 and B1 right there, that actually renders what is referred to as a specific indirect effect. It's the indirect effect of X on Y by way of the first mediator. Then if we compute the product of paths A2 and B2, which is reflecting the tracing from X to M2 and then M2 to Y right here, that renders a second specific indirect effect, with that indirect effect conveying that basically that the second mediator is kind of transmitting variation from X to Y. So we have two specific indirect effects of X on Y. And then theoretically, if we sum those two specific indirect effects, then what we end up with is a total indirect effect of X on Y. So taking a quick look at our the kind of underlying statistical model associated with our parallel mediation, you can see that we have two simple regression models that are given. So we have a regression of M1 onto X, then we have M2 regressed onto X, and then we actually have Y. I should just kind of highlight this. This should be a Y right there. Y that's regressed onto X, M1, and M2. And that's how we end up with the coefficients in our model. Now, finally, before we move into our examples, I do want to give you kind of a word of caution when it comes to running mediation analysis. Yes, the process, another way of talking about it is causal modeling. The idea is that you're modeling proposed causal associations among a set of variables. But just keep in mind that if you find that your model exhibits a reasonable or good fit to the data, this does not prove that your model that your causal formulation is correct in any kind of absolute sense. So a good fitting model is simply an indication that your model is consistent with your data, and that allows you to adopt your model as a provisional explanation of the relations among your variables. So in other words, model fit allows one to say that the model being tested is a reasonable candidate for explaining associations among a set of variables, but does not rule out other possible model specifications, basically alternative explanations, that may fit the data as well or better than yours. So this is why it's going to be really important when you carry out these types of analyses that you ground your model in substantive and well-reasoned theory. So now we're going to move into our first example. So you can see right here we just have a screenshot of the data, and I'm going to open up SPSS and run this in a second. But you can see we have our proposed model, and basically these are three of the variables that were included in the data set associated with that article I was referring to. So what we're going to be testing here is a model where we have task orientation as a predictor of autonomous motivation and intention to continue sport. Autonomous motivation is also specified as having a direct effect on intention to continue sport. So you can see right here, this is just basically a simple mediation model. And fundamentally, the assumption is that the effect of task orientation on intention to continue sport is both indirect by way of the proposed mediator being autonomous motivation, and possibly direct, which is reflected in that C prime path. So let's go ahead and open up SPSS and specify our model and generate our results. Okay, so here we are in SPSS. And the variables that we're going to be working with in this first example are the task orientation, autonomous motivation, and then this intention to continue variable right here. So we're going to go to analyze, go down to regression, and then to process. We're going to open this up, and we'll move our consequent variable, which is basically intention to continue, to the Y variable box. We'll move task orientation to the X box, and then we'll also move autonomous motivation to the mediator box. Now, in process, there are a large number of pre-programmed templates to carry out various analyses with different types of models. The model that we're going to select right here is model number 4. To carry out our basic mediation analyses. You'll notice too that we have number of bootstrap samples. By default, it's set at 5,000. You can raise that if you want to. Seems like a pretty reasonable number to work with. And just so you know that when it comes to the bootstrapping, what's going to happen is that we're going to end up with normal theory tests for all our regression parameters when we run our analysis. But in order to test the indirect effect of X on Y, or basically our task orientation on intention to continue, we're going to be using a 95% bootstrap confidence interval and to test that out. So we're not using a normal theory method, but we're using bootstrapping in order to test that out. So with this specification of 95 right here, that's also going to render a 95% bootstrap confidence interval. So under options, what we'll select is we'll go ahead and select show total effect model, and we'll go ahead and select standardized effects. And really that's all we're going to be working from in this particular example. So we'll click on continue and then on OK. And I should also mention too that when we are running the data that we're working with, we're basically assuming that all variables in our data set during our analyses are continuous. So now as we're looking at our output, you'll notice first off we have sort of a general description of our model. It says up here model 4, and it's got the Y variable, which is the intention to continue, the X variable being task orientation, the M variable being autonomous motivation. You also see the sample size, which is 269. And just keep in mind that process by default uses list-wise deletion when carrying out the analysis. So that is just kind of an important point to keep in mind. One other thing that I do want to mention, I'm just going to back up just a second here and go back to our menu right here. Let me kind of clear that off. You'll notice that there's this option right here for long variable names. And if your variables have more than 7 characters, if you don't check this box right here, then it's not going to run the analysis. Now, the thing is that according to Hayes, longer variable names can risk incorrect output. So if you happen to have longer variable names and you're willing to risk that, you can click on that box and then continue, and then it will carry out that analysis. Or an easier solution where you don't risk anything is just to simply make sure that your variable names have 7 or fewer characters. So at any rate, we'll move on back to our model, and looking at our results, you can see that we get a model summary up here. This is the first linear regression. This is a regression of this is a regression of the mediator in our model onto our antecedent variable. That is basically the autonomous motivation being regressed onto task orientation. So in this particular case, you can see that we get, there's our R-square value right there, 0.1731. You'll notice there's the F-test, there's the degrees of freedom due to the regression and the residual, and the P-value right there. You'll notice that, or perhaps you might notice situations where the headers for different, or labels for different pieces of the output may not be aligned very easily. I'm just going to draw your attention that, basically make sure that you are paying attention to the correct pieces of output when you're doing your interpretation. But we'll kind of go on down, and you'll notice right here we have the regression slope for that particular simple regression. So basically the direct effect of task orientation on autonomous motivation is 1.5144. That's the unstandardized direct effect. And you'll notice that we have a significance test. There's the p-value right there, and you can see that that effect is statistically significant. Then if we go down to the next outcome variable right here, we have intention to continue. That is regressed onto both task orientation and the proposed mediator, autonomous motivation. So you have the R-square value right there and F-test for this particular model. You can see that as a set, task orientation and autonomous motivation jointly account for about 14% of the variation in intention to continue, and the variance accounted for is statistically significant as reflected by this F-test right here. When we look at the path coefficients, you can see that the direct effect of task orientation on intention to continue is positive, but it's non-significant right here. And then the direct effect of autonomous motivation on intention to continue is significant right here. Just kind of keep in mind too that this is basically our path A right here. This down here, this would be path C prime. That's the direct effect of task orientation on intention to continue. And then down here we have path B right there. So there you go. So if we wanted to compute the indirect effect or the unstandardized indirect effect of task orientation on intention to continue, all we would have to do is take this value right here and multiply it by this value right here, and that will show up in the output as we proceed. The other thing to note too is that when we requested those standardized coefficients or fully standardized coefficients, this is basically the beta coefficient for the first regression model, and then these are the standardized regression coefficients for the second model. And so there's also, by selecting that option, we can also get the standardized or completely standardized indirect effect of task orientation on intention to continue. And there's also a bootstrap confidence interval for that. So we'll go ahead and scroll on down a little bit further. You'll notice that we have a total effect model. And in a nutshell, this is just a regression of the consequent variable and intention to continue onto our antecedent variable, which is a task orientation. So you'll see this is given as a regression coefficient. But if you recall earlier, I kind of mentioned that the total effect of a antecedent on a consequent is equal to the sum of the direct effect and any indirect effects involving that particular variable. So in a nutshell, this value right here, the 0.2965 that you see right there, is going to be equal to the sum of the direct effect of task orientation on intention to continue within this model up here. So I'll just kind of highlight the value right there. And also the indirect effect, which is computed as a product of those two regression slopes I was just telling you about. Okay, so we'll scroll on down, and then we have the indirect effects and bootstrap confidence intervals. So you'll see down here we've got the indirect effect of X on Y by way of the proposed mediator, which is autonomous motivation. So basically this value, the 0.2021, that again is the product of our paths A and B. We have the 95% bootstrap confidence interval that's given right here, the lower bound being 0.1211, the upper bound being 0.2971. So the way that we test this indirect effect is as follows. Essentially, we assume that the null of 0 reflects no indirect effect or no mediation that's taking place. So if 0 falls between the lower and the upper bound, then we would conclude that the indirect effect is not statistically significant, and hence it would be inconsistent with the proposition that there's mediation that's taking place. If 0 falls outside the upper and lower bound, as it does right here, and I'll just kind of highlight it right there, poorly drawn, of course, but it's falling below the lower bound of that confidence interval. So because of that, we would reject the null of no indirect effect and conclude that the indirect effect is statistically significant. So again, if 0 falls outside of the lower and upper bound of the bootstrap confidence interval, then we would conclude that we have a significant indirect effect, and that would be consistent with our assumption that there's mediation that's taking place. The other thing to note too is if we look at the down here, we've got the completely standardized indirect effect, and this is just basically computed as a product of the beta coefficients from those two models, the A and B paths for those two models. And once again, we see that 0 does not fall between the lower and the upper bound of the confidence interval. So we would, again, conclude that there's evidence of mediation that's taking place. or at least that the results are consistent with mediation. I do want to once again highlight that you're not proving mediation with this test. You're essentially testing a candidate model based on your theoretical conception about the relationships among these variables. And as we can see right here, we have support for our causal framing, but we do not have proof for that causal framing. Okay, so now we're going to transition into example 2. This is basically going to be our simple mediation model, but we're going to include some control variables. So in the data set, there's actually variables ego orientation and controlled motivation that are included. This model right here is in no shape or form what the authors were proposing. They actually were proposing in that article that the effects of task orientation and ego orientation on intention to continue sport is mediated by autonomous motivation and controlled motivation. So I'm just using this particular specification just to illustrate how you can include control variables or covariates in your analysis. So here we have, again, our simple mediation model with task orientation having direct effects on autonomous motivation and intention to continue sport, and autonomous motivation having a direct effect on intention to continue sport with the covariates of ego orientation and controlled motivation. If we break this down into the regression components associated with the statistical model on the left, you can see that we are essentially regressing autonomous motivation onto task orientation, ego orientation, and controlled motivation. And then we're regressing intention to continue sport onto task orientation, ego orientation, controlled motivation, and autonomous motivation. So those are the portions of the regression output that we're going to see when we run our analysis. So we'll go back into SPSS and we'll click on regression, go back to process. We'll move ego and controlled motivation down to the covariates box, and we'll leave everything else exactly as it was, and we'll click on OK. And it takes a second, but we're going to generate our results here. There it is. And just kind of taking a brief look at the model, you can see, once again, we've got model 4. You'll see the X, Y, and M variables, but now it says covariates, ego, and control right there. Our sample size is still 269, which you see right there. So when we scroll down, you'll see that we've got the autonomous motivation regressed onto the task orientation and ego orientation variables right here. And you can see that the task orientation variable was a significant predictor in this particular model. So the direct effect of task orientation on autonomous motivation is 1.3697 and is statistically significant. The ego orientation variable, while there's a positive regression slope right here, it would not be significant at the conventional 0.05 level. When we look at the overall model right here, there's the R-square value, and you can see the F-test is basically telling us, you can see it's significant right here, is telling us that these variables jointly account for significant variation in autonomous motivation. We'll scroll down a little bit further and we'll look at the regression of intention to continue sport right here onto these 4 variables. So we have the task and ego orientation and autonomous motivation and control motivation. So in this particular model right here, you'll see that our proposed mediator, the direct effect of the proposed mediator on intention to continue is positive and statistically significant right here. Whereas, and then also we see that the control variable ego orientation has a positive and significant relationship to intention to continue as well. So those are the only 2 significant effects within this model. Yeah, so there you go. There's our R-square value right there. There's our F-tests, and these variables are accounting for significant variation, in intention to continue. So now we'll scroll down and we'll look at the indirect effect of the indirect effect of task orientation on intention to continue while controlling for those two covariates within our model. So there's the indirect effect right there, the unstandardized indirect effect. And there's our bootstrap confidence interval ranging from 0.0909 to 0.2645. 0 does not fall between the lower and the upper bound of that confidence interval, so we would conclude that the indirect effect is statistically significant, as basically non-zero. Once again, we have our completely standardized indirect effect that's given right here, and you can see that that's also statistically significant as well. Once again, I do want to highlight that I know I'm going through this rather quickly, but if you go back through the PowerPoint that I mentioned earlier at the link underneath the video description, you'll get more detail with respect to this output. So for our third demonstration, we're going to be looking at parallel mediation. So this is the way I've kind of framed this right here. So we have the effect of task orientation on intention to continue sport being mediated by autonomous motivation and controlled motivation. And this is actually somewhat consistent with the author's original model, although there's also ego orientation, which is also included in the model as an antecedent, and it's also treated as predictors of autonomous and controlled motivation and intention to continue sport. So you could kind of think about this as being subsumed under that broader model. Just kind of taking a look at the regressions that are the statistical model associated with that conceptual model on the right, you'll see that we have a regression of autonomous motivation onto task orientation right here. So that's our A1 path. The regression of controlled motivation on task orientation, that's our A2 path. And then we've got regression of intention to continue sport onto all three of our variables, task orientation, and the two mediators, autonomous motivation and controlled motivation. So that's where we get the values for A1, B1, A2, and B2. And then also, although it's not really denoted right here, I'll just kind of note this as a C prime right there. Okay, so let's go ahead and run this particular analysis. We're going to go to Analyze Regression again, as usual. Go under Process, and instead we're going to take the covariates out of this box, and we're going to move the control variable in our controlled motivation in as a mediator. So this is our parallel mediation right here. So under Model 4, it allows for a single mediator or parallel mediators with multiple mediators. There are other models that actually allow for sequential mediation that we're not addressing in this particular video, but they do exist, and I'll get to those in another video. So let's go ahead and run this analysis. We'll click on OK, and takes a second, obviously, and there it is. Okay, so now looking at our output, once again, Model 4, and so now you can see those specification of M1 and M2, autonomous motivation and control motivation right there. So looking at our first regression, which is a regression, the simple regression of autonomous motivation onto task orientation right there, there's our positive and significant direct effect that's given in this output. Then, if we scroll down a little bit further, you can see we have, with respect to the regression of controlled motivation onto task orientation, there's a positive regression slope, but it's not statistically significant. So that part of our model is not supported. Then when we scroll down a little bit further, we can look at our regression of intention to continue onto task orientation and autonomous and controlled motivation right here. And of those three direct effects, the direct effect of autonomous motivation on intention to continue is positive and significant right there. So the direct effect of task orientation and controlled motivation on intention to continue, those direct effects are not statistically significant. So, in a nutshell, the proposition that controlled motivation may partially account for some of the association between task orientation and intention to continue that is not supported just by looking at what we see right here. But the formal test of it comes down below in the test of the indirect effects. So you'll notice that this part of our output right here, these are the unstandardized specific indirect effects. So here we've got the specific indirect effect of task orientation on intention to continue by way of autonomous motivation right here. So here we've got the bootstrap confidence interval ranging from 0.1116 to 0.2856. 0 falls outside of that interval. So that would lead us to conclude that the indirect effect is statistically significant. And so that's consistent with possible mediation that's taking place. Then we have the specific indirect effect by way of the second mediator, controlled motivation. So it's 0.0031. The 95% confidence interval ranges from negative 0.0104 to 0.0234. So in this case, 0 does fall between the lower and the upper bound of this particular confidence interval, and that leads us then to essentially maintain the null, assume that there's no evidence that controlled motivation mediates the effect of task orientation on intention to continue in sport. If you look below, you can also see we've got the completely standardized indirect effects and the confidence intervals associated with those as well. So here we have the standardized specific indirect effects and those confidence intervals that are given right here. And so once again, basically the indirect effect of task orientation on intention to continue by way of the autonomous motivation variable, that is significant, whereas the effect by way of controlled motivation is non-significant. Okay, so that was a lot to cover in this particular video. My plan is to address some other models, mediation models using process in other videos. But I hope you found this useful, and I appreciate you watching.